Hello, I've had a question for the 4U Physics, Lesson 8, question 56. What's the maximum speed a car can go around a flat curve, or a curve on a flat road if the radius is 90 meters, coefficient of friction is 0.5? Is it necessary to know the mass of the car in this problem? Let's take a look at the free body diagram. So the free body diagram. So I'm going to, don't need to put a diagram like this, but usually just use a dot, but I'm trying to make sure you understand that this, I'm looking at the tail lights of the car. All right, and here is my center of curvature. So that distance right there is 90 meters. So what forces are acting on this car? Well, we have force due to gravity, we have normal force, and then this is where it gets a little bit dicey here. Let me try to explain. We know that all our information, all the mathematics tells us that centripetal force, centripetal acceleration always goes to the center of curvature, and so is our centripetal force. Now, when we do a free body diagram, I always tell my students, draw it the opposite direction. So we're going to do centripetal acceleration outward, because that is where the momentum of the car wants to go. It wants to fly off the track. This is so the math works out, okay? What's keeping the car on the road is force due to friction. So what would happen in my engineering course, when I used to take engineering, I would draw the free body diagram like this, knowing that it's wrong. I would go ahead and do all my math, and then the very last thing I would do was I'd cross that out and draw it this direction before I moved on to the next question, because I know that is what it's supposed to look like. But for myself, it didn't make any sense in the free body diagram because it has all the forces going inward, so it should be flying toward the middle. So mathematically, what I tell my students to do is draw it in the opposite direction for the free body diagram, and then your math will work out, okay? Because if we're trying to find out our unbalanced force here, mass times acceleration, we say force centripetal is what's wanting to move this car outward, minus the force of friction equals ma. And for this question, the car is not going to slide sideways, which means it's not moving sideways, which means acceleration is going to be 0, making the right side of the equation completely 0. So then we end up with force centripetal minus force of friction. I'm going to do a lot of extra steps here that you won't mathematically, just for my explanation, which therefore means that centripetal force has to equal force of friction for this car to go around the curve without sliding off. All right, now it's just a matter of going through and substituting in our formula. So we know that force centripetal is mv squared over r. Force of friction is mu mg. All right, from force of friction is mu Fn. Fn is just Fg in this case, which is mg. And this will answer the second part of the problem here. Why do we not need to know the mass? Well, mass appears on both sides of the equation and will in fact cancel out. All right, so mass cancels. All right, in that step there, so that's why we don't really need to know the mass. And we are looking for, what was the question? Maximum speeds. We're looking for v. So v squared equals mu rg, or v equals the square root of mu rg. And you can substitute numbers in at any point here. It doesn't really matter. I like carrying it through. Less writing for me. 90 and let's call it 10 because its safety factor is going to go on here anyway. So 9.81 versus 10 won't make that much of a difference. Times 90 times 10 square root, that's not square root, it's 1.5, and I get 21.2 meters per second. And the reason I don't worry about it in this course, the reason I use 10 for gravity, here's a perfect example. I'm going to look at, this curve, 21 meters per second is how fast you can go around it safely. Traffic engineer is going to come along and say, okay, you know what, maybe, but let's call it, we're going to say 15 meter per second speed limit on it. That way we have a safety factor because people are going to speed. So if you see 15, they'll do 20, et cetera, et cetera. But that conversation's for another day. Anyway, so therefore, max velocity is 21.2 meters per second. Now, after moving on to some of the other questions, when it's on a slope, okay, this is moving on to questions 57, 58, something like that. when it's on a banked surface, FCX, in my video, I make a mistake and just use MV squared over R. Depending on the device you're watching, there should be a pop-up bubble that comes up and says that cos theta should be on there. If you look at your formula sheet, it has the cos theta as well. So if it's on a sloped surface, you need the cos theta, which would MV squared cos theta R would go in there. But that's a different question. Just hopefully heading off some future frustration for you. If you have any questions further to that, let me know, and I will try to explain it a little bit better.